let me remind you that the other day when we talked about the properties of parallelograms, special properties, one of the things that we learned about a rhombus was that if the diagonal of the parallelogram, if the diagonal of the parallelogram bisects the opposite angles, then we know it's a rhombus. In other words, if this is x plus 2 and this is x plus 2, this is x plus 2 and this is x plus 2, we know we have a rhombus on our hands. We also know that, well, essentially we have an isosceles triangle here, because if this is a rhombus, then that means these two sides have to be parallel to each other. I'm sorry, congruent to each other. So basically what we're saying here is that we can say that this is x plus 2, okay? So if that's x plus 2, then that means this is x plus 2, and this is x plus 2. And it looks like we're interested in the measure of angle L, so I suppose we might as well focus on this triangle down here, although they're both going to be, both triangles are going to be the same. So we know that the sum of the angles in a triangle is 180, so we can say that x plus 2 plus x plus 2 plus angle L, we don't know what that is, all has to equal 180, right? So what expression for the measure of angle L? So let's get angle L by itself, and we're going to have an expression that represents what it could be, what it should be, in order to be a rhombus. Let's add our like terms together. We get 2x plus 4 plus angle L is equal to 180. Let's get angle L by itself. And now we have an expression that says 180 minus 2x minus 4. I'm just doing algebra here. So we have angle L is equal to 176 minus 2x. That expression would make this a rhombus.